Good afternoon. My name is Peter Childs and I'm co-director of the Energy Futures Lab at Imperial College London. I'd like to welcome you to the launch of our new briefing paper, Accelerating the Transition to Heat Pumps. There are pressures to move away from the use of hydrocarbon gases in our homes, so this paper is both timely and important, looking at the potential impacts and feasibility of one approach to supporting a transition to heat pumps, leveraging early adopters by measuring in-situ heat pump installation outcomes and sharing these as case studies to enable peer-to-peer learning amongst consumers and installers. In a moment, the author, Dr. Richard Carmichael, who's here with us on this event, will join us to present the paper and its conclusions. For those of you who are joining us for this type of briefing paper for the first time, a short introduction. The Energy Futures Lab is one of seven global institutes at Imperial College London. It was established in 2005 to address the world's major energy challenges by bringing together teams from a variety of research backgrounds to carry out multidisciplinary and high impact research. Today's event is going to last an hour, and you should be able to see the agenda on your screens now. There'll be a presentation lasting 15 minutes from the author, Dr. Richard Carmichael, and this will be followed by remarks from our external panel, whom you're going to meet in a few moments. We'll then move to a question and answer session with the presenters and the panelists for the final 25 minutes of the event. There'll be an opportunity to submit questions through the Q&A feature in Teams as the event progresses. We're likely to be only able to address a handful or several of these questions. So please read the questions carefully, or the ones which are submitted. And if you don't mind, like the ones you want to draw our attention to the most, and we'll make sure those are featured. The event's being recorded and we'll make this available on our YouTube channel. We'd encourage you to, of course, share this recording with colleagues who aren't able to make it today. The briefing paper itself is already available on the Energy Futures Lab website, and you'll be able to find the link in the Q&A feature. So now, to introduce the paper and give the presentation, I'd like to hand over to the author, Dr. Richard Carmichael.
Yeah, great to be presenting this. Finally, it's been quite a while in the making, and it's quite a long briefing paper. So getting right into it. There's a lot of topics, so I'll have to cover some of them quite briefly. So some background before the aims of the paper. Why are we talking about heat pump transition, and why do we want one? Well, basically, heat in homes is responsible for a huge portion of an average household's energy use and carbon emissions, and heat pumps are viewed as probably the best option for decarbonising heating in homes for the majority of homes. And even with the present grid mix of generation, they can offer between 2/3 and 3/4 carbon reductions compared to using gas in a gas boiler. So they're widely accepted to be playing a very important role in the decarbonisation of heat in buildings. And there's targets, some more ambitious than others, but they're very much in doubt about whether we're actually going to reach these targets. It's been calculated that at the present rate of adoption of heat pumps, it's going to take 700 years to get to the CCC's target of 19 million heat pumps by in order to meet the net zero goals. So what are the main challenges that we're going to face and cast doubt on the progress towards these heat pump adoption targets? Well, essentially, it's going to involve households choosing to switch from familiar, trusted and fairly cheap, at least until recently, heating appliances, gas boilers, and choosing heat pumps, which are quite unfamiliar, not common, not really trusted or known. And it doesn't help that in certain sections of the media there's a sort of a trickle of articles that cast doubt on whether they're a cost-effective option. So essentially, householders and landlords have got a lot of uncertainty and many questions, any one of which would probably be enough to derail an adoption decision. So people don't really feel that they know what it would cost to run after it's installed, their doubt about whether it would keep them warm enough, whether their home's ready for one. And even if they're committed to the idea in principle, there's a whole load of decisions about, well, which make and model, how much work do I need to do to my home in order to sort of make it work efficiently? Do I need to replace radiators with underfloor heating? Perhaps the bore of the piping needs to be thought about. And then, could I run it on a time of use tariff? So lots of questions. And these are actually, many of them are actual real genuine evidence gaps for even policymakers. They have to think about some extra things too. And on top of the supply side issues, there's the demand side problem of a lack of skills in the installers to put in heat pumps. So in that context, the aims of the paper are to address 4 questions. How do we support consumer confidence and informed adoption decisions better? How can we also support the upskilling of installers? We need more, and we need them to be consistently good. And how do we fill the evidence gaps that policymakers need to worry about to support householders and consider the grid and energy security and flexibility, etc. So all of those will require some data and learning, and where's that going to come from? The paper focuses on looking at the feasibility of one specific approach which could contribute substantially, and that is essentially the idea of measuring the real world performance and outcomes of heat pump installations, leveraging that by sharing this widely on some sort of public database. So this has been an opportunity to dig deeper into this than was done before. So I'm going to be talking about information and data a lot. So kicking off with the main point that energy consumers looking at adopting products and services need detailed information and advice. This is widely accepted by governments and the CCC, and for unfamiliar and complex technologies like heat pumps, you need even more detailed information. So against that, there's a problem because householders are not getting accurate, reliable information on either buildings or heat pumps, which are both of which would be required to make decisions about what heating system to install. Building sides, EPCs, where people get most of their information from about their building and what they could do to improve it for energy. They've been strongly criticised by a number of organisations for their reliability, which is problematic because different assessors come up with slightly different results. Their accuracy, which is obviously based on estimates, not measuring, and uses the SAT methodology, and sometimes outdated assumptions. And also criticised on their metrics, which are very heavily focused on price, and so they don't recommend heat pumps as a rule. The image there is Scottish Government's suggestion for a different set of metrics, which more clearly separate price. And on the heat pump side, people aren't getting information that's useful to them, or it could certainly be better. After installation, heat pump performance and efficiency isn't measured or assessed. Before installation, consumers do get an estimate or forecast from the installer. Unfortunately, this is based on how the heat pump should perform as a product, sort of standalone. And when some researchers compared the forecasts with the actual in-situ installed performance of the heat pump within the heating system, there's little correlation between the two. So that's not a good basis for making decisions about adoption. This is some work by Colin Meek that's kind of shows the difference between the forecasts and the actual performance. So what's the sort of scope for actually measuring things in buildings and heat pumps instead of estimating them quite inaccurately? There is some work being done still on the EPC action plan, and also more ambitiously perhaps the building renovation passports and metered energy savings work. These are very much in progress, but could improve on the situation. But more interest, I think, is the findings that have come out from the SMETA project last year. SMETAs are smart meter enabled thermal efficiency ratings, and they have demonstrated that it is possible using smart meter data and sensors to calculate the actual heat loss of a building with more accuracy than an RD-SAP calculation done by an expert, and also more reliably than EPCs. So that's looking positive, the feasibility for buildings. On the heat pump side, at the moment, there's no requirement to meter heat pumps afterwards for the boiler upgrade scheme. But before that, the renewable heat incentive did require that some heat pump installations were metered. So although we are now facing less data on actual performance, the renewable heat incentive experience does show that you can meter and measure the in-situ performance using heat meters, electricity meters, and temperature sensors. So although they're not being measured, they can be for both buildings and heat pumps. So that's the measurement side. Moving on to the sharing side, it's obvious that at the moment we're very much in the innovator adoption phase of the diffusion of innovation cycle by sort of diffusion of innovations theory. So we might want to be thinking about, well, how can we support innovators at this time in the cycle, and they will lead on to others adopting later. But we also need to consider, what is it about heat pumps that we can support, the characteristics of this specific innovation. And unfortunately, with heat pumps, there's three characteristics that are associated with slower diffusion of innovation and adoption. Their relative advantages, as diffusion of innovation theory calls it, which means essentially, are they better than gas boilers, is unclear. The financial value case is unclear, doubts about comfort, etc. All those questions I mentioned before. Also, observability helps adoption, but heat pumps are not really that visible, not like solar panels, which have been found to cluster because people can basically get influenced by their neighbours. And also, you can't try out a heat pump like you could try out an EV, and it's an expensive purchase, so that's not helpful. But peer-to-peer learning could perhaps help with all three of these. So you may not be able to try it out yourself for a month or so, but you can learn from other people who have bought one and installed one and what they found their experience to be. And this could also help clarify the value case, and also help normalize and make it more visible, perhaps digitally seeing adoption. And peer-to-peer learning with heat pumps has already been demonstrated essentially, and the influence that it can have has been seen in Finland through online forums where people discussed heat pumps, and that was found to be really instrumental in their takeoff of heat pumps in that country. So we don't have that at the moment in the UK, and also perhaps we can do better. So how do we enable peer-to-peer learning? In heat pump forums, people are very engaged, and it takes a lot of time, and it gets a bit complex. So we need to make it easier than that. An example to follow, perhaps, is the laudable example of the Green Homes Network in Scotland. So the only limitation with that is that although it gives text and videos and quotes from householders, it's lacking the real sort of numbers that are going to make this more impactful on adoption decisions. People need to know in detail what were the outcomes. So essentially we can say we need numbers, not adjectives, which is stolen from David Mackay's point applied to a different discussion in energy policy. So we need the measurement to back up the case studies. So the proposition is that you measure, that informs case studies, which allows you to have ex post assessments of outcomes with some real hard data. And you also have the customer satisfaction experience, the more qualitative reviews of installers and heat experience, etc. And these can be extremely influential. The CMAs have discussed how influential customer reviews can be. And then the second part is you share this on a public database, and that has to be obviously useful and engaging and allow you to search for similar homes to yours, etc. And that will being trusted is going to be important as well, which means verifying the data. So how does this translate into improving the customer journey? Well, this is the current situation where you have estimated only assessments of buildings. If we have measurement of building performance to start with, that can improve the system design for the heating installation. At the end, when you get an ex-post assessment of the actual outcomes of the installation, that can go back, if you like, and allow people to check if their heat pump performance forecast was accurate. Perhaps unlock finance as well, and ongoing monitoring could improve system performance and optimization. The second stage would be sharing this. So if those that data and case studies go into a public database, you then have a situation where you can leverage that data much more. Installers can start benefiting. They can learn as well. They can have this rich resource of case studies to sort of discuss and learn from. And of course, customers' decisions will be improved as well by seeing what worked for other people and what could work better for them, and generally be reassured. And of course, this is going to improve outcomes as well, not just adoption decisions. And as this cycle goes through, the case study database gets larger. So I've mentioned installers and consumers, but there's actually 4 groups who could benefit and use a case study database. So the installer side I've mentioned, just want to stress the transparency of the database would incentivize excellence and hopefully weed out the installers who can't improve enough, and also enable them to do so. And on the consumer side, that transparency is also going to have the effect of providing better customer protection than this current situation, because you will have installers' competence being driven up. 2 other extra users and beneficiaries would be researchers able to look at some of the evidence gaps. This database could generate a very big set of data, very varied, compared to, say, field trials, which are relatively expensive. And that data and research on evidence gaps is also going to be really interesting for policymakers to think about the distributional impacts and policy to support adoption and grid flexibility, etc. So a really useful set of data for various users. And this kind of benefits for multiple stakeholders has been identified by BEIS as a really critical thing for change and for a successful heat pump transition. And hopefully it'll grow as the database grows and adoption is stimulated and supply is stimulated, so that it will have an increasingly large impact as the feedback loop between adoption and case studies and upskilling carries on. So before wrapping up, I just want to mention 3 quick points on data sharing. Yes, this will be a bigger data privacy issue than, say, sharing smart meter data with a price comparison website, and it will require informed opt-in consent, especially to keep the data in the sort of case study format, which will be pseudonymized. But there are things which may outweigh that. People would have an opportunity to take an active role in a heat transition, and there's public support for clean energy. And people are generally quite willing to share their experiences in customer reviews, and this has been seen in the Green Homes Network and online forums, etc. Finally, the recommendations at the end of all this for government, basically calling for support for developing standardized procedures, some of which I've discussed, that can measure the in-situ performance of buildings and heat pumps, perhaps require, and this would obviously grow the database a lot quicker, that all installations have to do this ex-post in-situ assessments, and potentially make it part of the compliance with the minimum COP required in heat pump performance for the bus scheme, and support the development of the database, which obviously needs to have kind of trusted oversight. So probably don't have time to go through the key points, but that's where I'll leave it today. Thanks.
Richard, thank you ever so much. That's really helpful. So we're going to now move into a period where we're going to introduce 3 panelists, and they've been kind enough to read the paper in advance, so they know it well. They may actually draw out some of those key points for you, Richard, anyway, over the next few minutes. can I just encourage everybody, we've got 124 attendees, to use and look at the Q&A function. And if you want to upvote any of the potential questions, that would be great. Or if you've got a new question, just announce it there and we'll get to those in due course. So let me introduce our three panelists. We have Dr. Matthew Aylott. He's electrification of heat lead at the Department for Business, Energy and Industrial Strategy. I just call it BEIS, but quite rare to see it in its full form, but there we go. And in this role, Matthew's responsible for leading the government's work to enable the deployment of 600,000 heat pumps by 2028. You're going to need a lot of installers. And prior to joining the civil service, Matthew was a senior energy policy advisor at the Consumers Association, which, and policy manager at the UK Energy Research Centre. So looking forward to Matthew's 3 or 4 minutes on the briefing paper after I've introduced the other two panelists. We also have Maxine Freck, and she's worked at Ofgem for 15 years in a range of roles, most recently as senior partner networks. She's now an independent consultant and thought leader in the energy space and has taken a particular interest in the challenges around heat decarbonisation. She brings a strong consumer perspective, chairing SGN's Consumer Engagement Group and as a member of SSEN's group. We also have Nathan Gambling, as he's a heating engineer, lecturer and consultant who's taught plumbing and heating in colleges and in a prison. As well as industry and teaching qualifications, he's got a degree in behavioural studies and is regarded as a leading expert around training and the learning process within the heating industry. He hosts the award-winning renewable heating podcast, Beta Talk. So 3 people fantastically qualified to respond to this paper. And we're going to go in that order and just invite each of them 3 or 4 minutes each, kicking off with Matthew.
Thanks, Peter. So yeah, firstly, thanks to Richard and the team at the Energy Futures Lab for inviting me onto the panel. And secondly, thanks to Richard and his team for writing a fantastic paper, even if it does bring home some uncomfortable truths to us policymakers. So people will, I hope, be aware that we've got some ambitious plans for heat pumps. But I think critically, the paper highlights a major issue, that making these big changes to people's homes and the transition to heat pumps will certainly be a big transition for many. It can be quite complex. So we need to make the technology simpler for users to understand. And we've started on this road. We've recently published heat pump user guides and case studies from our electrification of heat demonstration project. As well as our new check if your home is suitable for a heat pump calculator, which is available on Gov.uk. But more clearly needs to be done, and we're supporting some exciting projects looking to do just that through our £60 million Heat Pump Ready Innovation Programme. That being said, making people aware of the technology and improving the consumer journey is only part of the solution. We also need to make heat pumps a compelling offer to consumers, one that's too good to refuse. And the paper flags a very important issue around running costs, which is an issue particularly close to my heart at the moment, given the situation that we find ourselves in. And clearly a heat pump might never be as cheap as a gas boiler to buy, but it can be cheaper to run. And that's been a key selling point for electric vehicles over the past decade. Some people will find that installing a heat pump will reduce their bills, while others will find that it won't. And we want all heat pumps to be cheaper to run than their fossil fuel equivalent. And we think that will incentivize people to make greener choices and move this more into the mainstream market beyond those early adopters. To do this, we're taking action to remove policy costs from electricity bills, which was a commitment of the new Prime Minister. We're also improving installation standards and increasing the performance of heat pumps through better insulation, better fabric performance of buildings and product efficiency. But the paper also highlights the fact that most people find it difficult to work out whether a heat pump could actually save them money. And often the estimated performance of a heat pump bears, as Richard has said, no correlation to the in-situ performance, and this certainly needs to be addressed. The same is obviously true of any heating system, particularly a gas boiler, but historically people haven't been concerned if their gas boiler is running at 85% efficient or 92% efficient. Problem with a heat pump is it's less forgiving, and the evidence that we've had through things like the electrification of heat demonstration project suggests that this performance gap could be quite significant, 50% or more. And it requires a competent installer to get the installation right, and a user who understands how to get the best out of their system. So I'll just end by saying shortly we'll be publishing more data from our electrification of heat demonstration project that will hopefully demonstrate the performance gap, but we certainly welcome the recommendations of Richard's paper, that more needs to be done, and this could include, and something again close to my heart, the greater use of smart meters to monitor performance, and that's something that we're actively seeking to do.
Matthew, great. That's really encouraging. So the second of our panelists, Maxine, over to you for some commentary, please.
I can't unmute.
You have unmuted very well.
Oh, okay, I'll carry on. Sure. You know, again, really supportive of this piece of work, and you know, the importance of data in this space. One of the many hats I wear as an associate with the charity Sustainability First, and as part of that we did a big project on the role of smart meter data to inform public policy across a range of areas, but probably the biggest one that we pulled out was heat, and Richard kindly flags that PAG work in his paper. And indeed we christened the phrase that he's picked up about policymakers will be flying blind into the energy transition unless they get better data. So while our focus was on policymakers, we absolutely recognise the importance of data for consumers and installers. And another piece of work that I've done involved looking at, you know, the range of different heating options that are out there, and that heat pumps aren't going to be right for absolutely every household. There is a bit of horses for courses, and again, you know, getting the data to understand how they're working and where they are right is crucial. And that point about the real world operation rather than you know, how they operate in situ, rather than just what it says on the kit. You know, Matthew kind of alluded to it, but I mean, we have seen the issue with gas boilers, which we've suddenly all discovered. Condensing boilers don't actually most part condense because their flow temperature is set wrongly, and you know, and that is a problem across almost all gas boilers as far as I can understand, and nobody really understood that and knew that, and we've been wasting 10% of our energy to date because we haven't properly been monitoring how those installations are used in practice, versus the installers who just want to get in quickly, do a quick job and get out. We need to really be tracking and understanding the performance in situ and making sure that these things are delivering, and to fine tune them. You know, there's a lot of people I know with heat pumps, you know, there's some fine tuning that needs to be done, and that support to help customers after they've got them installed is important. I think it's also, you know, and it's a bit more on the policy side, but anybody in the energy space knows the importance of flexibility. Most of the documents I read just assume that heat pumps will be flexible, and some real understanding about actually in practice, can they be flexible, is very much dependent on the building fabric and how they work. And so that is crucial if we are going to be able to deliver a heat pump rollout without putting undue strain on the wider system. Similarly, energy efficiency gets talked about as a way the networks could avoid network reinforcement is through the improving the energy efficiency of our homes. But again, one of the problems they have is that there isn't the data to demonstrate the benefits in terms of the impact on heat pump usage and on the demands on the network. So again, that kind of data is crucial. So absolutely behind these recommendations. I think advice and support will be vital to customers, and better data can help that be delivered in a more cost-effective way. So the recommendations that you've got all make complete sense to me. We pushed in our PIAG work some other recommendations more broadly about improving BEIS statistics and the CERL database that UCL run, but we did also include a recommendation in our report that wherever there were heat pump trials being carried out, that the electricity consumption smart meter data should be recorded at the same time. It seems daft to be paying money for innovation projects, paying money for customers to have a heat pump installed through BUS and then not be collecting the data. I think it would be not at all unreasonable for BEIS, to make getting the data a condition of if homes are getting support to get a smart meter installed.
I'm going to stop you there because we're going to pick that up in Q&A actually, because it's one of the high voted questions. Nathan, your reactions, please.
Hello, everyone, and thank you for inviting me. One of the first things I always like to say is that the word heat pump, the term heat pump, is very, very generic. Heat pumps exist everywhere. So millions of people today will be heated by heat pumps in their offices, if they're working in retail, if they're working in shops, etc. When you look up and people say, oh, that's air conditioning, that keeps me cool in the summer. It also keeps you warm in the winter. They're VRF systems. They are heat pumps. Anything that moves heat from an evaporator to a condenser using vapor compression is a heat pump, which basically means they're everywhere in this world. The Costa coffee machine keeping your milk at 5 degrees in that petrol station you perhaps went to this morning is a heat pump. A slush puppy machine is a heat pump. They literally are everywhere. There's probably more compressors on this planet than humans. Obviously, when we talk about heat pumps in the domestic centre, people have tended to concentrate on air source to water source. So the ones I've just talked about in your office that people just think keep them cool, they're air to air. So the thing I really liked about this paper, obviously Richard and I discuss and chat quite regularly, and I set up something called Beta Teach, which is all about activating engineers as learning resources for one another. Because peer-to-peer learning is a very natural thing to do, and if we juxtapose learning with education, they are two very different things, and obviously I'm interested in how we learn to put heat pumps in. So education is ritualistic, it's not natural, it's content driven rather than context driven. So they'll get people like me and write courses, etc., and then we'll dump all this information in front of engineers and expect them to remember it, whereas something like Richard's model that he's discussing is context. So now if an engineer turns up to a premises and they've got some challenges, they can look at a case study perhaps that's relevant. It might be something that's built with flint, thatched roof, they're umming and ahhing, should I use 28mm rather than 35mm pipework? They can look at a case study and instantly they've got a performance aid. I often talk about this thing of courses to resources, which is a term coined by Nick Shackleton-Jones. Excellent book if anyone wants to read it, how people learn. He coined the term courses to resources. We all use resources. If me and my 9-year-old daughter wanted to learn how to bake cookies, I wouldn't sign up to some e-learning course or go to class. We'd YouTube it. And resources are performance aids. A lot.
I believe we've lost Nathan. So until Nathan comes back, I'm going to jump to the Q&A session. And I'm sure Nathan will come back and we will pose him the relevant question, like what was he going to say next? But I just want to kick off with one of the high upvoted questions on Q&A. So it's this one. Data may work with professionals. It won't persuade most consumers to act or change behaviours. I'm sure you can see the question. It needs a story and personal face-to-face with a trusted person. So Matthew and then Maxine, your responses to that question.
So I couldn't agree more, and I think it's essential that we have a sort of consumer engagement campaign to support all the amazing data that we are publishing and finding from various trials and innovation projects. And we are embarking on a consumer engagement campaign in government, trying to make people more aware of the issues around installing heat pumps and the benefits of installing heat pumps. As I said, we've produced user guides and case studies, video case studies, as well as written case studies to try and engage different people. And we've also got these very simple to use online calculators. All of that helps, but we can't do things in isolation. We need to work with industry. We need to find different ways of communicating with different audiences. We can't treat everyone the same. But I couldn't agree more. I think it's a really essential part of the journey.
Maxime, are you willing to add to that question? Okay, I'm going to move to the, oh, Richard, would you like to jump in there on that one?
Yeah, sure. Maybe Maxine can come in again afterwards. Definitely. Yeah, I mean, it's a fair point. And in a previous life, I was a narrative psychologist, so I do get the importance of story and narrative. But I would push back quite strongly that, A, we don't need every single person to use the database. But I think a big chunk of people will be able to digest a simplified, very accessible, user-friendly table of what your install costs were, a star rating for the installer, what your bills are. People can understand numbers like that, and it's not just professionals, and it doesn't have to be super technical. So one of the challenges on the project that will be taking these ideas up, which Matthew alluded to, which I am involved with, and it's just been announced this week, is how to make it design the database and the case study format in a way which doesn't, scare people, and you can have perhaps layers and give people control as to how much technical data they want access to. So initially you may just have very basic kind of top level sort of stuff, which is not going to be baffling to anyone. But yeah, it's a challenge, and case studies can be made into stories quite easily.
Brilliant. Maxine,
so can you hear me now?
We can indeed, please proceed.
So, I mean, the other point I was going to make was things like the calculator that Matthew referred to. The key there is that you're getting some accurate information out of that calculator, and that, it isn't discredited by then proving to be inaccurate in the real world. So that's where the data comes in making the information that's provided more robust, rather than being a source of masses of information that would bamboozle customers.
Thank you very much. Nathan, are you loud and proud now?
Can anyone hear me?
We can indeed. I'm going to give the next question to you, and then maybe ask Richard to jump in as well. And it's the question regarding, well, the flow direction of the heat pump can be reversed, and with increasing number of cooling degree days, should heat pumps be advertised as a combined heating and cooling solution? In the US, we've got a lot of evidence of this. So your reaction to this question?
Yeah, I mean, air-to-air is a very simple technology to reverse. I mean, the indoor unit becomes the evaporator in the summer, taking heat out. In the winter, it becomes the condenser. When it comes to air source to water source heat pump technology, it's a little bit different. If you've got underfloor heating, it can be done. Certain manufacturers have that option. Radiate is not so much. It's obviously something that people are going to be thinking about. Obviously, lots of people now are interested in keeping cool, obviously, in the summer. And this is where, again, now people are becoming a bit more aware about heat pump technology. There's nothing wrong with putting an air source, air-to-air, especially if you've got a flat. I mean, you can get a 4 kilowatt outside unit for 500 quid, an indoor unit for 200 quid, £1,000 to get an F-gas registered engineer, put it in, job done. So it's actually quite cheap technology, air-to-air stuff. And like I say, it exists, literally. It exists at the BBC and the radio stations where you get people come on and say they don't work because my family put it there.
Great, thank you very much, Nathan. Richard, your reaction to...
Yeah, briefly, I could say that I don't really need to take a position on the importance in the future of cooling as well as heating. In a sense, what I'm kind of presenting today is a methodology for shedding light on exactly these questions. So I could be agnostic about it, but what we'll hopefully get is real world experiences and case studies and stories and data, and then we'll see. You know, this is a way of answering that question and a lot of other questions. But if we don't start measuring and sharing stuff, we're not going to answer any of them.
Okay, so we have a data question which I'll pose to Matthew and then Maxine. Do we think we should put the same requirement around post-install monitoring on gas boilers as we do on heat pumps, you know, in order to make a level playing field? Matthew.
I mean, it's a good challenge, and I think clearly there are issues with performance and realising the condensing nature of a gas boiler or a boiler in any regard, and that can affect performance of fossil fuel boilers. So yes, I think there is a need to create that level playing field and to highlight the issues around performance with fossil fuel boilers as we do with the performance of heat pumps. But as I mentioned, I mean, the contrast is more stark with a heat pump, and the performance drop can be more significant. And with electricity prices as they currently are, that can be quite prohibitive and can have a really significant impact on the performance of the heat pump system. So there's an added onus on making sure that a heat pump system is installed correctly, and it delivers what it's expected to deliver in terms of its performance.
Sounds like we're going to need to improve education in our universities so that everybody understands what a coefficient of performance is versus an efficiency. Maxine.
Yeah, so I mean, I agree with what Matthew said there. I think just building out onto Richard's report is that, you know, there's also this is a whole new area for installation of heat pumps. So there is a sense in which people are used to being able to work whether the gas boiler is doing roughly what it says, barring the, you know, the little bit of 10% efficiency that we're missing on the condensing side, whereas the heat pumps is a completely new experience for people, so they don't know what they should be expecting, and they don't have friends and family that have got one either to tell them what to do. So I think it's a good question, but I think that the need is even greater on the electricity side.
Okay, I'm going to go to the one of the last questions. They had less time to get upvotes. So many of us have PV panels. Some of the people on the presentation today have talked about PV panels, and the report does as well. And of course, owners of PV panels get detailed information on the performance of their systems, and some of us are data junkies. Can heat pumps deliver something similar? Nathan, I'd like to come to you with that one to start with.
Can they deliver something equivalent to PV?
No, can they deliver? So people get excited about the data and the performance information they get from PV.
Yeah.
Is there something equivalent that we can do with our heat pumps?
Without a doubt, and that's where it comes back to measurement again. If you've got people monitoring performance, it does engender conversations, and we learn from conversations. Again, if you know, the education model is all about lecture, learning is actually about conversations. It's reciprocal, so we can learn. You know, the engineers at the moment are using these computer-mediated communication platforms such as social media, and they don't go on social media to learn. They go on to what's colloquially known as their banter. But if they want to use each other as resources, they say, "Look, I've got this challenge with my heat pump. What do I do?" They can pull on each other as resources, and it's become very beneficial. So Richard's idea of kind of formalising that a little bit more in a structured way is great, and measurement's so important. I mean, you can go to heatpumpsurvey.com and get a proper measured survey of your home. I mean, U values it can do for small properties, but it doesn't always get you the right information you need. Richard,
go for it.
Yeah, I just want to add to that. Yeah, I think potentially, definitely, it could be something that could really grab people. But I would say it's not necessarily heat pump compared to PV, because when it gets really exciting is if you have heat pump plus PV, perhaps plus a battery, and even time of use tariff. That could be very exciting to see. Well, I'm generating my own power, I'm storing it for when I need it, then I'm running the heat pump at 300% efficiency. yeah, I could get quite interested in the data if you put things together like that. And again, this sort of stuff and these sort of different variations of technologies would be great to capture on a wide basis, where you grab the data in a sort of a crowdsourcing sort of approach. You don't have a trial just to look at this and spend loads of money. You can just grab whatever people are doing and trying, and some of them are going to have great results, and you're going to want to learn from all of it.
Matthew.
Perhaps I can just jump in and throw a slight spanner in the works. So the question was raised about whether we should be metering and monitoring all of our heat pumps, and I think the truth is we should in an ideal world, but for example, with the renewable heat incentive, we monitored about 5,000 heat pumps as part of the renewable heat incentive, but it cost a lot to do that detailed monitoring. So we were providing incentives of about 1,500 quid to get people to adopt the additional monitoring requirements. What we need to do going forward is find a much simpler way of monitoring people's performance, and lots of heat pumps already, provide detail about their coefficient of performance, and we're taking action to make sure that all heat pumps are smart by default, so that enables you to do more with the data, accessing smart meter information, and I think that's the key. I think keeping it simple, keeping it cheap, and making sure that people do have access to that information, so if they choose to use it, they can.
All right, thank you very much. We have a complicated question from Nigel Lloyd. There's a tendency to only consider air source heat pumps, but others, ground source, water source, etc., are more efficient at the time of greatest need, really cold weather, and act as seasonal heat storage. Great, this is where it gets complicated. He then says, we need, or do we need to consider small group shared heat pumps and other variants? Matthew, I'm going to put this one to you initially, and then you can throw it to one of the other panelists.
I think that's an excellent point, and yeah, we do need the diversity. We can't just support one technology. There needs to be different technologies, and just thinking about that in the context of air source heat pumps versus ground source heat pumps, or shared ground loop systems, these communal systems. So an air source heat pump, we found through the electrification of heat demonstration project, the in-situ performance might be about 280% efficient. A ground source heat pump could be 330% efficient, so delivering 3.3 units of heat for every unit of electricity that you pump into it. They also, because the ground temperature is generally higher than the air temperature, or more consistent, that might mean that you can, at times of peak demand in the middle of winter, you may be able to mitigate some of the peak constraints on the electricity network. So shared ground loop systems, ground source heat pumps in general are very good, and we are supporting those systems. But more data is needed. Data is king, and clearly there is a need for more data, which Richard has already highlighted, and communicating and getting that information out is going to be key to sort of driving those policy changes to really deliver the rationale for why we need perhaps uplifts or incentives, additional incentives for those kind of systems.
Maxine, are you willing to take up that question as well? No. Richard, over to you.
Well, actually, I was thinking of Maxine's line, horses for courses, which applies in this situation. Absolutely. Think we need to be looking at other technologies as well. I have been talking about heat pumps for various reasons, but the sort of my argument is that this should be applied to other technologies. As Maxine's pointed out, storage heaters can work well in small flats. It's not all about heat pumps everywhere. So yeah, any sort of innovation on shared heat ground loops or whatever it is would benefit from, seeing what's been what the outcomes really are, and then sort of sharing them again. So it definitely applies to innovation and new technologies and new solutions.
Nathan.
Yeah, definitely both technologies are important. I just want to, the statistics Matt just mentioned, 280%, 330% interest, because that's all we ever get from these studies. The Energy Savers Trust 09-11 studies, the Ofgem studies, all we get are these statistics. We don't learn from them. You know, there's no more data, which is what Richard suggests. But I would point out there's a lot less engineers putting in ground source. Some of them tend to be a lot better at knowing what they're doing. With air source, you will get a lot of people not really knowing what they're doing and just putting these things in. That's why you tend to get lower performance, these percentages for air source, because it's you know, it's easier for people to go and to get their certificates that they need to go and put air source in. Your ground source engineers are going to invariably usually be a little bit more clued up. So that's one of the reasons, because generally they are starting to even themselves out. You know, it's the advantage of ground source is you've got a constant temperature in the ground, roughly about 7 degrees. Disadvantage is when it's milder, 10 degrees outside, your air sources start to be a bit more better at performing. But that's
you want to sell us 2 gadgets, don't you? Very good. We're going to come to our last question, and it's from Rhiannon Turner, and really talking about energy performance certificates, and can there be grants available for more interventions perhaps. So she says the upgrade grant is not available if there's any outstanding installation recommendations on the energy performance certificate, but no grants for most people for those upgrades. There's a disconnect. Richard, if we can come to you, because you've been looking at this so much over the last several months or year.
Oh, sorry. So the question is about some of the restrictions on the availability of grants are not appropriate. I wouldn't argue with that. I'm not sure that I got much to say about, other than one of the benefits of this approach of case studies is to hopefully simplify for people who are not sure about what they're eligible for and not sure what grants and support is available, because you'd be able to certainly include in the case studies cost paid out for the installation was this, support from grants and funding was that, and you'd be like, oh, okay, right, yeah, that's clear. I know what, hopefully it helps me decide what support I can get. Yeah, that's about all I can say.
Maxine, are you able to pick up this question as well on energy performance certificates and grants and eligibility, ineligibility?
I think, I mean, the biggest issue I would flag out of that is how it affects different households differently. So if you're a relatively well-off household with you know, and you're told, well, you've got to do this bit of insulation before you have your heat pump installed, you can afford it. But for others, you know, so it's very much thinking about making sure that those on the lowest incomes can still afford to participate and aren't left behind. It's one of the mantras that we have, but that's really about making sure there aren't blocks in the rules around applying for grants.
Thank you very much, Maxine. Matthew, inevitably this one's going to come your direction as well.
Well, without wanting to give away the future of our policies and policy development, what I will say is we are reviewing the grant requirements for all of our programs, and we're also reviewing EPCs to make sure that they support the transition to low carbon heating. So I probably shouldn't say anymore, but yeah, leave it with us perhaps.
Okay, very good. I'm going to close down this session now. So thank you ever so much to all of our panelists, to Richard, Matthew, Maxine and Nathan, and to everybody who's joined. Please do download the paper. You'll receive a link by email, and there's also a link being placed in the Q&A function. And if you go to our website for the Energy Futures Lab, you'll find many briefing papers around the territory of energy supply and energy demand on the Energy Futures Lab website as well. So we hope you will join us again soon for another Energy Futures Lab event. Thank you very much, everybody.